we've got a secondary substrate, the good leaving group. We'll recognize this as the tosyl or toluene sulfonyl leaving group. We've got a species that's both a good base and a good nucleophile and a polar solvent. We have to consider SN2 and E2. So it's a secondary substrate, but there's a lot of beta branching. So there's a good bet that it's going to be E2 if that is a possibility. So where can we do E2? Well, we can, remember this is a methyl group, so we could do E2 here. That would leave me a di-substitute, or actually a mono-substituted alkene. Or I can do an elimination here, which would give me a tri-substituted alkene. So this is going to be favored, but of course for E2 I need a proton anticoplanar to the leaving group. This proton, as drawn, is not anticoplanar to the leaving group. So let's rotate around that bond, and I'll use some shorthand to make the pictures easier. So let's stay with methyl here, hydrogen up, and tosyl group here. I've rotated 180 degrees, so my proton is in this location, anticoplanar to the tosylate. That brings the phenyl group out and down, and the ethyl group down and in. Okay, so now I have an anticoplanar arrangement, and I can consider the E2 reaction. So that would be my E2 reaction, and you can see then that the phenyl group and the hydrogen are going to be cis to one another, and the ethyl and the methyl are cis to one another. So this is my product. E2.